Hi, welcome to Lesson 18F, Integrating f of ax plus b. The goal of today's lesson is to become proficient at integrating functions that are composite of linear functions. So we've developed the fact that if we were to integrate something like x squared, for example, plus dx, that we increase the exponent by 1, and we also have to notice that the coefficient of x squared in this case is 1. Therefore, if you were to differentiate x cubed, you would get a 3 as a coefficient, but here there's just a 1. So in order to counteract that 3 being multiplied in here, we have to divide by 3 or multiply by 1/3. And then, of course, add the constant of integration. Okay, so we've looked at that kind of stuff. So now we run into issues where we've got composite functions where we've been able to integrate the other functions. So, like the main function, I guess. So if we have the integral of sine x dx, well, when you differentiate, and we go back a step, if we differentiate sine x, that gives us cosine x. If we differentiate cosine x, we get negative sine x. So if we have sine x and we want to go back, we're going to be transforming this into a cosine, because when you differentiate cosine, you end up getting a sine, but the sine x is actually negative. So to integrate this, we go back to what it would have been, which is cosine x and then plus c. But we need to say, okay, well, if we differentiate this now, that cosine x becomes negative sine x. So, but we see we've got a positive coefficient here, so that means that we have to start off with a negative. Okay, so then when you do differentiate cosine x, that gives you a negative sine x. If you differentiate this, that gives us a negative sine x, which then becomes a positive sine x, which is what we want. Okay, so I always have to sort of think one step ahead in order to get back to what we want the integral to be. Okay, if we have, let's stick with trigonometric for example. If I'm differentiating, let's say, cosine 3x plus 5, for example, that'll be the c. Then in differentiating this, we differentiate the trigonometric function itself, so we get sine 3x, and then we differentiate the angle, and that in this case gives us 3, and then of course that plus 5 just goes to 0. So I bring this 3 to the front, so to simplify this I get 3 sine 3x. Okay, so if I'm now to take the integral of cosine 3x dx, then I know by differentiating it, we're going to be bringing that 3 to the front like I did here. But when you integrate this, I see that I've got a 1 as the coefficient. So what I need to do is I need to counteract that 3 being multiplied, so I'm going to multiply by 1/3, and then the integral, the opposite of, or the integral of the cosine, well, if I differentiate sine, I get cosine, so if I go back, I need to have sine x, and then plus the constant of integration. So we need to keep these kind of things in mind, and we also have to see what else would happen with that angle as we multiply. So then if we differentiate this, the sine x, when we differentiate, becomes cosine, and then when we differentiate the angle, that 3 would be multiplied by this, just like we had over here. So we're multiplying by 1/3 to undo that multiplication by the 3. If I'm differentiating something like e to the 5x plus 1, well, the derivative of e to the x is just e to the x. So this is e to the 5x plus 1, but then we have to differentiate the exponent, which in this case is going to be 5. So then to simplify, we get 5 e to the 5x plus 1. So now if we're going to integrate e to the 5x plus 1, for example, then, well, by differentiating, we get the same thing anyways, so the integral of this would just be e to the 5x plus 1. But when we differentiate, we had to again differentiate this linear function, the exponent, so we get that 5 here, which we bring to the front. But here we see that there is no 5, it's just a coefficient of 1, so I'm going to multiply this by 1 over 5, and then add the constant of integration, so that when I do check this and I differentiate this and get e to the 5x plus 1, which is what we have, and then we differentiate the exponent, which gives us 5, and we multiply the 5 times 1/5, which gives us the 1. Okay, so let's now take a look at another ejemplo. We'll take the integral of 3x minus 4 and the square root of that. Well, I like to rewrite these roots as exponents, so that's going to be exponent of 1/2. So now I have to think again and think, okay, well, if this is the result of a differentiation, or the derivative, what was that exponent before? Well, instead of subtracting 1, as we do when we differentiate, we have to add 1 to that. So I'm adding 1 to 1/2, so I get 3/2. So now I look at this and think, okay, that's great. If I differentiate this to check it, this 3/2 would come down in front to leave me with an exponent of 1/2. Okay, so that's good. However, there's an exponent of coefficient of 1 outside the bracket. So if I multiply 3/2 by something and get 1, that something must be 2/3. Okay, and then also if I were to check this and differentiate, so I brought the 3/2 down in front, multiply by 2/3 to get the 1, then I go inside and subtract the 1 from the 3/2 to get 1/2. Then I go inside and to differentiate 3x plus or minus 4, and that gives us 3. Well, again, it's still a 1 out front. So when I bring the 3 in front, when I multiply that, when I differentiate, that has to be counteracted by a division by 3 or a multiplication by 1/3. Okay, so 3/2 times 2/3 gives us 1. 3 times 1/3 gives us 1. So that checks out here. The exponent gets reduced by 1 to give us 1/2. We add the constant coefficient, of integration, and then we just simplify up front here. So we get 2 over 9 3x minus 4 to the 3/2 plus c. And I often like to return this to root form if it was given in root form. So I would say 2 over 9 3x minus 4 cubed and the square root of that plus c. Okay, let's take a look at the integral of e to the 7 minus 3x dx. Well, like we had up here, when you differentiate an exponential function, it just gives that exponential function again. So I would be safe to write e to the 7 minus 3x. So if I differentiate this, I just get e to the 7 minus 3x. When I differentiate the exponent, I'm going to get a negative 3 that comes down. But here, again, we just have a 1. So in order to undo the multiplication by negative 3, I have to multiply by negative 1 over 3. And then add the constant of integration. So to check that, I take the derivative, e to the 7 minus 3x results, and then the derivative of the exponent would be negative 3 times negative 1/3, which gives us 1. Okay, so that checks out. And then let's look at the integral of 2 cosine negative 4x plus 1 dx. So, well, the integral of 1, that's just easy, that's x, so that's fine and dandy. We already went through that the derivative of sine would give us cosine, and so we've got cosine here, so we have to go back, so that'll give us sine. So it'll be sine negative 4x, and here's our plus x here. I'll add in the constant of integration plus c. Now to check this, I take the derivative of the function, which gives us cosine negative 4x, which is fine. I then take the derivative of the exponent, or sorry, the angle, which then gives us negative 4, and we multiply the negative 4 to the front. But it's not negative 4, it's actually positive 2. So in order to counteract that, I would multiply the front here by, I can say negative 2 over 4, which I'll simplify in a second. So when I check this, negative 4 times negative 2 over 4, the 4's cancel, the negatives become positive, and you're left with a 2. So that can then be written as negative 1/2 sine negative 4x plus c. So that's the basic idea of integrating the functions that are composite functions with linear functions. There's a few questions that I would like you to take a look at. There's a couple examples in the textbook which would be pretty handy to also see. And so once you take a look at those, I'd like you then to take a quick perusal. Sorry, I keep saying that, but a quick perusal, that's oxymoron. Just glance at these questions. You can maybe do a few of them if you wish, but you'll have time in class to work on these anyways. So it would just be from pages 464 to 465, 1 B, D, F, G, H, 2 C, F, H, I, 3 for A, B, D, F, 5 B, F, 6 at F, 7, 9, 11, and 12. Okay, so those will be the questions I'll be asking you to practice on tomorrow in class. And in the meantime, check out the examples in the textbook and just glance at those briefly. So thanks for watching, and we'll see you in class.